do another example. Does this series, the sum from n from 1 to infinity of minus 1 to the n minus 1 divided by square root n, does this converge absolutely? And so, just as before, let's take absolute values here. And so when we take absolute values, we obtain, so the absolute value of minus 1 to the n minus 1, that's always going to be either plus or 1 or minus 1, and then when we take the absolute value of that, we always get plus 1. And so this is the series that we're left with. And maybe it's a little bit more suggestive here. We write square root n as n to the 1/2, because now we should be able to recognize this is a p series with p is equal to 1/2, and that's less than 1. So this series diverges. Okay, so what do we conclude here? Does this series converge, the original series, does this converge absolutely? No, it doesn't converge absolutely. But a question that we should ask is, does the sum from n from 1 to infinity of minus 1 to the n minus 1 over square root n, does that converge at all? And so right now the answer is, we don't know. Just because our series doesn't converge absolutely, so because when we take the absolute value here, we get something that diverges here. So this original series, it does not absolutely converge, but that doesn't mean that it doesn't converge. So we're going to have to develop some more tools. So in the next video, we'll develop a tool that will allow us to determine whether or not this converges. And in fact, it does converge. So this series does converge. We just don't know yet how to show that. But this should inspire a new definition to think about. So here's a definition of conditional convergence. So an infinite series, the sum of a sub n, it converges conditionally if the original series converges, but the series, when you slap absolute value bars on the individual terms, if that series diverges. That's our definition of converging conditionally. So go back to, go back to the title of the section, absolute convergence and conditional convergence. Here's our definition of conditional convergence. Here's our definition of absolute convergence. So from now on, our questions are going to be of the form, I said this in the first video, they're going to be on the form, does the series absolutely converge, does it conditionally converge, or does it diverge? So it absolutely converges, that means it converges, and the sum of, and when we slap absolute values on it, that also converges. It conditionally converges if it converges, but if we slap absolute value bars on it, it diverges. And then diverges is just diverges from before. So in the next video, we'll take a look at a method that will, a theorem that will allow us to show that this series actually does converge.